Hello Year 8, this is lesson 11 in the Forces, Waves and Generating Electricity booklet. At the end of our last lesson we had a look at this word grid and what we've got to find is the renewables and the non-renewable sources of energy. Here's the answers. So last time we had a look at tidal. We've done tidal already. There it is. Let's have a look at some of the others now. Wave. There's wave. Knock off wave there. Hydroelectric. A geothermal. A biomass. Once living matter. Wind. And solar. Right, that is all the renewables done. Now let's have a look at the non-renewables. I'm going to colour these in blue. We have nuclear. We've got oil. Yeah, oil. We should have natural gas, yes. And finally, king coal. Where are you? There it is, there's coal. And give yourself a mark out of 11. So let us move on. Just have a read through the passage here. The hint here is coal. It's a type of energy, non-renewable. So I think it should be coal power along with gas and oil and nuclear are all types of non-renewable energy. Coal, oil and gas power stations release CO2 into the Earth's atmosphere. This unfortunately increases global warming. Now we have here a picture of a nuclear power station. Nuclear power is obviously, pause the video, you have a go first and then see if you get the right answers. Here we go. Nuclear power is a type of non-renewable energy. A nuclear power station does not release extra carbon dioxide. Oil, coal and natural gas power stations do. Nuclear power stations do not release CO2. So they are not directly involved in global warming. Now then, wind turbines. Wind turbines are a type of renewable energy. The blades are moved by the wind. Wind turbines on top of mountains produce more electricity because the wind speed is greater on top of the mountains. You don't have to look too far away from room 39 to see some A, mountains and B, wind turbines. They are part of the future. Hydroelectric power stations. What are they? They're a type of... my mistake. They are a type of renewable energy. Hydroelectric power station use moving water to generate electricity. Now we have some people in what looks like a hot lake. It's geothermal power. Geothermal is a type of renewable energy. It uses high temperature rocks far underground to heat the water up, to produce steam, to spin the blades of a turbine, to generate electricity. Solar power is a type of renewable energy. It's constantly being created, mostly as a result of the action of the sun. Solar cells convert light energy directly into electrical energy. You see solar cells in things like digital watches and calculators. Very useful. Now we go on to an ICT opportunity. If you were to go on to Google and put into Google the two words grid watch Templar, you will come up with a screen that looks a little bit like this. And in fact, it'll look exactly like this. This one here. But that's at like an odd angle. So let me try and explain to you what you're going to get. You're going to get some results. You're going to get some dials. And it's real-time stuff. It really is quite interesting. So this tells me how much electricity is needed in the UK at this moment in time. Now, obviously, your value when you log on might be different to that because of the time of day or what season we're in. Like, for example, in winter time, near Christmas, the amount of electrical demand is huge because people are warming up their houses with electric radiators. They've got all the lights on because it's dark, and they've got the Christmas lights on as well. So the demand will be larger than in summer. Now, let me just try and explain this number here. 42.6 gigawatts is 42.6 times 10 to the power 9 watts. What does that mean? Well, 10 to the 9 means 10 times 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 10. But we've got 42 of them. In fact, 42.6 of them. I'm going to write this out in another way. Now, don't worry about powers of 10. It's just a little introduction. Right, let me just check. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I've put in one too many zeros. Let me just try that again. 10 to the 0, 1, 2, 3 is 1,000, 4, 5, 6 is 1,000,000, 8, 9. Oh, no, that's correct. Watts. Boom, boom, boom. Yeah. 42 billion 600 million watts of electrical power is needed by the UK. What does that mean? It means that we need 42 billion 600 million joules of electrical energy every single second. All you need to appreciate is the UK needs a lot of electricity. Now, where do we get that electricity from? There's the demand. That's what we need. Where do we get it from? Well, let's have a look at the sources of how we generate electricity. This one here, 50%, just over 50% of the electricity we need comes from burning natural gas in gas turbines. Almost 15% of our demand comes from nuclear power. Just over 7% came from burning wood or other once living material like crop waste. And then, so they're the main ones, they're the biggies, but how else do we meet this demand? Well, you can see here, must be windy on this day, 14.27% was generated by the wind. Hydroelectric, just almost 1.5%. Solar panels produced 7.56%. And coal. Coal used to be the major generator of electricity. It was once almost 70%. Now look, it's down to 3.12% on this particular day. We even buy or sell electricity to the French and to the Dutch and to the Irish. Now, the negative value for France, minus 2.79, and for the Dutch, minus 0.50. The reason that has occurred is because we are generating so much electricity at the moment that we've got a surplus. We've got too much. So we are selling it to the French and to the Irish at that particular moment in time. Now, it works both ways. It's a partnership. So it may well be that sometimes we buy electricity off the French and off the Dutch and off the Irish. So what do I actually want you to do? First off, you could draw out a table of the results that you are getting on that particular day. Maybe take a screenshot and print it off. You could generate a pie chart of this information and then choose a renewable source of energy and provide a brief explanation of how it works, together with a picture of maybe one of those power stations and the advantages and disadvantages of this type of electricity generation. This is just an interesting little project for you to have a go at, okay? That will do for this lesson. Well done today.